A very good morning to our doctor. My name is Kirti Kumar and my metric number is 823A1953. Today we will like to present our assignment on statistical data analysis based on an insurance dataset for application of mathematics and statistics in business subject. First of all, I would like to introduce my group members. First, Kishanta, M. Roshni, Siti Fahanim, Yashwin, and last myself, Kirti Kumar. First introduction part. Statistical data analysis is the process of gathering, arranging, evaluating, and analyzing data to obtain useful information and support decision making. It is widely used in both academic and business field because it helps identifying trends, relationships, and patterns in data. Through statistical analysis, organizations and researchers can make decisions based on facts and evidence instead of assumptions. In this assignment, the data set consists of several important variables. The first variable is age, which is a numerical variable representing the age of individuals. Next is gender, which is a categorical variable. BMI or body mass index is used to measure body fat based on height and weight. The children variable shows the number of dependents covered under the insurance plan. The smoker variable represents whether the individual is a smoker or non-smoker, while the region variable indicates the residential area of the insurance person. Lastly, charges refer to the annual insurance cost paid by the individual. Next, we move to benefits of statistical analysis. There are several benefits of statistical analysis in the dataset. First, it helps identify factors that may affect insurance charges, such as age, BMI, and smoking habits. For example, smokers may have higher insurance cost compared to non-smokers. Statistical analysis also allow us to compare different groups of people and better understand the data through charts and numerical results. Therefore, this analysis is important because it supports better decision making and planning in the insurance industry. That's all for my introduction section.
I am Hemaroshni Chandran, matrix number A23A1848. Today I would like to present sampling and data selection process. For this analysis, we used a random sampling method in IBM SPSS statistics. Random sampling is important because it helps us choose data fairly and reduces bias. In this dataset, 496 cases selected from the first 553 cases. This determined by the first listing down all the group members' matrix number. For instance, if the last two digits of your group members' metric number is 4, 14, 48, 48, and 53. The smallest number would be 4 and the largest number would be 53. This implies that you would select 496 cases from the first 553 cases where 496 results from 500 minus 4 and 553 results from 500 plus 53. Then, first, the dataset was opened in SPSS by clicking File, Open, and Data. Then we went to the Data menu and select the option which is Select Cases. After that, the random sample of cases option was chosen and the sample size, which was determined using matching numbers, was entered by clicking the Sample button. Next, the Delete Unselected Cases option was selected so that only the chosen data remained. Finally, we clicked OK to complete the process. As a result, SPSS showed only the selected cases and data was ready for further analysis. This method helps make the analysis more accurate and reliable.
My name is Krishanta and my matrix number is A23A2540. Today I would like to present descriptive statistics. This table shows the descriptive statistics for 496 respondents focusing on age, BMI, number of children and insurance charges. First, the average age of the respondents is 39.73 years, indicating that most insured individuals are middle-aged adults. The age ranges from 18 to 64 years with a standard deviation of 14.63, showing a wide distribution of ages. Second, the mean BMI is 30.66, which falls within the overweight category. BMI values range from 15.96 to 49.06, and the standard deviation of 5.95 indicates a moderate level of variation among respondents. Next, the average number of children is 1.04, meaning most respondents have around one child. The standard deviation of 1.21 suggests that the number of children is relatively similar across respondents. Finally, the average annual insurance charge is Ringgit Malaysia 13,216.23. The charges vary greatly, ranging from Ringgit Malaysia 1,137.01 to Ringgit Malaysia 63,770.43. The high standard deviation of Ringgit Malaysia 11,794.91 indicates significant variation in insurance costs, which may be influenced by factors such as age, BMI, and individual health conditions. This section discusses the measures of position, namely the median, mode, and quartiles. For age, the median is 40 years and the mode is 19 years. The first quartile, Q1, is 27 years, and the third quartile, Q3, is 53 years. This means that 50% of respondents are between 27 and 53 years old. For BMI, the median is 30.35 and the mode is 26.60. Q1 is 26.60 and Q3 is 34.42, indicating that 50% of BMI values fall within this range. For the number of children, the median is 1 and the mode is 0. Q1 is 0 and Q3 is 2, showing that most respondents have a relatively low number of children. For insurance charges, the median is RM 9680.05 and the mode is RM 1137.01. Q1 is RM 4753.88 and Q3 is RM 16808.14, meaning that 50% of respondents have insurance charges within this range. Since the mean is higher than the median, the distribution is positively skewed. In conclusion, age, BMI, and the number of children are fairly balanced, while insurance charges show greater variation due to some high values. Age. Histograms of age representing the age of the insured shows a relatively even distribution, as the mean age of 39.73 years and the median age of 40.00 are nearly identical. This indicates that the sample represents a good distribution of adult ages, but there would be a clear peak at 19 years old, the mode or the age that appears most often in the data. This graph would be helpful to the insurance industry because they would be able to see the age groups of their plan holders, which they will be able to understand their target groups. Count of smokers. The pie chart for smoker status used to compare the percentage of smokers to non-smokers in the dataset. This is a key visual tool as smoking behavior is recognized as a significant determinant of insurance costs. The chart shows these two categories, making it easier for researchers to see how large the high-risk group smokers is in relation to the low-risk group non-smokers to make a better decision and to plan for insurance.
My name is Siti Pahani binti Muhammad Asri, number metric A23A1714. I will present about hypothesis testing. Hypothesis testing is a statistical method used to determine whether there is enough evidence to support the assumption. The objective is to examine whether the differences, relationship, or effects observed in a sample are statistically significant or occur by chance. It helps the researchers in making accurate and reliable conclusions and reduce biases when making decisions. Hypothesis testing involves two hypotheses: null hypothesis (HO), hypothesis that will be tested, and assume no effect or no difference. Next is alternative hypothesis H1, hypothesis that is considered as an alternative to the null hypothesis. It assumes there is an effect or difference. T-test is statistical test used to determine whether there is a significant difference between the means of two groups. Hypothesis statement HO. There is no significant mean difference between charges and the smoker. H1. There is a significant mean difference between charges and the smoker. The graph that is shown is bell-shaped. Thus, the data is normal. P-value is 0.001. Thus, HO is rejected.
Hello doctor, my name is Yashwin Anarki Thailand and my matrix card is 823-821-04. Today I would like to present my part which is ANOVA. Let's look directly at the primary ANOVA table, show that picture. Our department variant here is a charges. We have a total sample size of 496 individuals spread across 4 groups, as indicated by our total degree of freedom of 495. Now, the most critical number on this slide is the final column. Our significance value or P value, which stand at 712. As a reminder, standard practical look for a value below 0.5 to claim statistical significance, because 712 is the most higher than 0.5. Our F statistic of 485 is not statistical significance. Let's look the ANOVA effect sizes. To double check those findings and understanding the magnitude of many positional difference, we also have looked at the effect sizes, which you can see in the lower table of this picture. If you look at the eta square point estimate, it is a 0.003. This tells us that the grouping variable account is the more 0.3% of the variance in charges. The remaining 99.7% of the variance is due to other factor or random variation within the group themselves. Furthermore, the other metrics like epsilon square and omega square hovering around 0 or even show slight negative adjustment, confirming that the actual effect of a grouping on charges is practically non-external. For a difference to be considering statistical significance in this study, we are looking for a value less than 0.5. In the Tukey HSD section, our significance value range from 954 up to 998. Even the more liberal LSD test, the lower significance value we see is 284 for comparison between the northwest and the southwest. Because every single one is the dose value is much higher than 0.5, we can conclude that none of these resident pairs have a statistical significance different in charges. We can also verify this by looking at the 95% confidence interval. You will notice that every comparison, the range between the lower bound and upper bound include the number 0. For example, comparing the northeast and northwest, this difference could be as lower as $285 or as higher as $5020. In statistics, if a confidence interval contains 0, it means we cannot confidently say the real difference exists. The influences we see in the main difference column likely just do like stapling verification. In conclusion, this study analyzing 498 responding to identify the factor affecting medical insurance charges. The descriptive statistics show that the average age was around 40 years old. The average BMI was 30.66 and the average insurance charge was 13216.23. The independent sample t-test found the significance difference between smokers and non-smokers, showing that smokers pay much higher insurance charges. This indicated that the smoker is a major factor affecting medical insurance costs. Meanwhile, the ANOVA test showed a significant difference in insurance charges across different regions, meaningful, the location has little influence on insurance premiums. Overall, smoking is the stronger predictor of medical insurance charges, while religion has minimal impact. This finding highlights the importance of a healthy lifestyle choosing in the reducing medical and insurance costs. Thank you.